10.2 says, hence or otherwise prove that cm squared over dc squared is equals to am over ab. Now here we recognize that they are quite, there's am within this expression, and am is not a side that we have dealt with yet. So what we can do is we can construct a new relationship. We are gonna prove that this big triangle here is similar to this other big triangle over here, and that's quite easy to prove since we already see that a1 is equals to a2. So a1 is equals to a2. That has already been proved. Then from there we see that m is equals to c. That's also already been proved, or not proved but given. And then the last angle, we know that will be true as well. So you can either call it c1 plus c2 or acm. So acm is equal to b, and that is the third angle of triangle. Will always be similar if two of them are already equal. So from this we can draw that triangle AMC is equal to triangle ACB, and the reason being angle, angle, angle. Then from this we just have to now draw something similar to this. So we see CM, and we see, what else do we see? We see AM and AB. So we just have to try and play around with these ratios such that we get something similar to this at the end of the day. And we can start by saying AC over AM is equal to the same thing on this side, AB, or is equals to BC over MC. So AC over AM is equals to BC over MC. Okay, so this way would be a bit tedious. So before we continue with this, let's see if we can optimize this. So these aren't equal, but they're similar. And since we know that, we already know that ACB is similar to DMC, then we can formulate another one. We can say triangle AMC will be similar to triangle AMC will be similar to triangle ACB, which is what we have. But we could also say AMC is similar to triangle CMD, which we have already used before. So now we're working with the small triangle and the bigger triangle outside it. So that basically working within this framework, just within this. Now we can see it's a bit easier for us to form exactly what we need, because I see, what do I see? I see AM. So the trick is just to try and find similar things within these coefficients and then try to recreate that. So we can say in this case CM squared, we can create that by using CM, because we see CM here, we also see CM over there. So if I create CM here, it's gonna be AM over CM. And then since I started with AM, which is first and second, here I'll go first and second, which is CM over CM here was second and third, so that would be MD, like that. If I cross multiply, I'll get that CM squared is equals to AM times MD. like that. Then now I have one part of it, so I have cm squared is equals to am, the top part. I need to find a way to cancel out this md. So we need a way to express md. For that, we will use a different ratio. So let's use that in a different color. We can say from the first one that we originally had, the one of triangle ACB. So triangle ACB was similar to triangle CMD. In this one, we could say, since we're trying to create DC in this problem, we see that there is BC and DC, but we know BC and DC are equal. So BC is equals to DC. So I'll create BC on top here, and I'll have something like BC all over MD. So you can cross them, and this will be equal to AB, which is also the first two over here, over CD, or DC rather. BC being equal to DC allows us to replace BC with DC or substitute, and be left with MD is equals to AB over DC. You cross multiply, you get DC squared is equals to MD times AB. And again, we've created the bottom part. DC squared is equals to AB. DC squared is equals to AB, and the MD now cancels. If we take the ratio of cm squared over dc squared, this will be equal to am times md all over ab times md. MD cancel, we're left with am over ab. And that's your answer.